going on. Okay, so um, I said we are going to try to solve this exercise, and we need to add. We didn't add all the functions for the three reliability averaging techniques. We did for the first two. If in case you don't have the third one, we'll add the third one and solve the exercise. So this is, yeah. So as you can see, we have the k arithmetic, that is for the first one for the horizontal flow. We have the k harmonic for the vertical flow, but we didn't add any function for the k geometric. So we should add that and then um, find the permeability average for um, a random flow, which is using the k geometric for this system with these permeability values. Okay, so you see that the k geometric here, for all the permeabilities that you get, you have to find the product of those permeabilities. So if there's, let's say, 7 permeabilities, you find the product of all 7 permeabilities. Then you raise it to the power 1 over the number of permeabilities you have. So in case it is 7, you raise the product to the power 1 over 7. So that is how you average the permeabilities. There are multiple ways you could do this. You have the math module prod, you can use that, or you can use the prod function that we added to the script in the last um, session. I'm going to do both, and you can see, you can decide to use the one that you like. So I'll go with the first step using the prod and the prod function from the math module. So I'll define the function. It is geometric and it's going to take only k. For the geometric calculation, it doesn't need the height, so just the k values. And we will import the math module, and then we'll use the math module's prod to calculate this. So I'm just going to call the return and just find it the way it will be. So prod of the list that will take. So that is basically solving um, the expression inside the bracket. Then we raise it to the power the length of k 1 over the length of k. So 1 over, if it is 7, you know that the length function return a number of elements in the k list. Alright, so this is using the math module method. You can use the prod function that we have here. So in this case, you just use the prod function. So you can say return the prod of k, and then we'll raise that to the power of the 1 over the length of k. So it's up to you to decide which one to go for. All of them will give you the same result. Okay, so I'm just going to take one off so that we don't have repeated functions with the same name, and I'll save that. So when you edit your script file, you see an asterisk to the name of the script. You can save it by holding Ctrl S or Command S. Then you can restart the session again so that Python will be aware of the changes that we've made. So you go to runtime, then you go to restart session. You click on yes. So now with the session restarted, now we can get our key. The key is from 10 to 50. Or it's actually 10 to 50. The 40 was just misplaced here so that you not know that it is in progression. So I'll just say k equals range of 10 to 60 of step 10. So we'll have our k from, if you wanted to see the values in this k, we'll have our k from 1 all the way to 50. So 10, 20, 30, 40, and 50. So that's the k that we have. Now we need to provide the path to the script function to be able to import the how do you call it? Import um, the k geometric function we just wrote. So we'll import our system, and then we'll use the system dot path dot append, and then we'll add the path to the script module. So you locate the script module in your Google Drive, and then you copy the path. Then all you have to do is to paste that, and you're only interested in the location, not the script itself. And make sure that that is in between quotes, either double quotes or single quotes, it all works fine. Now we can import the script module, and then I use the script.kgeometric, and then we can find permeability for this system, and that is what we have. So this is what we are doing up until this point. I hope everybody is clear with this. Is there any issue with this? Okay. Yeah, yeah. Okay. So we are done with this. Again, today we'll be reading files or importing files from other software, specifically Excel. So I've sent some files into the group. Please make sure you've downloaded them and you have them. So suppose that you have a file like this. I should have opened this down. It's fine. Why is everything slow today? So here we have an Excel file of permeability and height values. So these are something that you can be provided um, by geologists. So you have the permeability take of a formation taken at various heights. So permeability at this height, permeability at this height. So these are the permeabilities, and you'll be given these permeability values from an Excel file. How do you import them into a Python file so that you can calculate the average permeability of the entire reservoir? That is the question. So before you can um, use the file you just saw in your Colab, first of all, you need to upload the file to your Google Drive. So you open a new tab, and then you go to Google Drive. You can type Google Drive in the browser. Why, why? And you go to your Google Drive, and then everything is slow today. Yeah, so you can basically drag your file into your Google Drive, or if you have folders in your Google Drive that you want to put it into, you can drag the file that I just downloaded and put it into your Google Drive, and it will be uploaded into your Google Drive. Okay, so you can do it. The files are not big, so it will not take any time to upload. So after you've uploaded the files, we'll need to import them. And if you uploaded the files, if you come to your Google Drive, you should find. If you don't find it, restart the session again. Just like how if you edit your script file, you restart the session. If you upload um, a file into your Google Drive, restart the session, and if you look for it in your Google Drive, you'll find it. So mine is what's it called, data. So it is here, data.excel. So this is the data. How do we get it into our Python Colab? That will use a module called pandas. This is one of the libraries we're using heavily in machine learning. It's for dealing with data analysis and processing. So we'll be using pandas to um, just like how we have the math module, the pandas is for dealing with data from other sources like Excel. So we are going to import pandas. Usually the pandas name is alias. You can use the pandas as it is. So I'm not going to change it because that's all we know. And so we can call pandas, and there is a method or there is a function called read Excel. So it's for reading Excel files. And then all you have to do is go and look for the path of the data set you just uploaded. So you copy the path like you do for your modules, and then you paste them here. So if you run this, we should see our Excel file uploaded. And so this is the Excel file. So the permeability and then the height. So we have it. So we are going to store this inside a variable. It can be anything. I'm just going to use df for data frame. We call Excel files or table files as data frame in Python. So that is just what I've shortened as df as the variable name. Okay. So I've stored the Excel file inside this data frame. Yeah, I'm listening. Can you speak up a bit? Yeah, yeah, yes, yeah, yeah. So for this one, we um we wanted to import the script file itself, but Python doesn't know where it is. So the append here, we are only telling it to go and look for it in this folder. We don't want to add the script file itself to the path because this thing doesn't read files, it only reads paths. If you add the script file to it to give you an error, that's how we delete that. So for the path function here, it only reads paths. If you add the file itself to the path, it will give you an error. But in case of the pandas, we are reading the file, so the file has to be attached to the path where the folder where the file is. One is interested in the folder, one is interested in the path, the file itself. Okay. Right. So how do we get the values that we just had into let me print it here so that we can see it. Okay, it's very long. So how do we get this into a list so that we can use it for our calculations? So just like how you can index and the value, the elements in a list, you can index the columns um, in a data frame. When I say data frame, I mean any tabular sheet in a data frame by indexing their column names. So if I call the f, which is the variable name I'm storing the data frame inside, and then I pass the square brackets like you know, and then I pass the name of the column, I should get I don't know, k permeability. Okay, it's capital D. So this is the this column, but we don't want it in a column form. We just want the values. So you add a method called value so that we only get the values in a list, not as a data frame or as a column. So when you pass dot values, we'll get the list of the values of the permeability column in a list. So you can store that as k, and you can do the same thing for the height as well. Yeah, so we'll just be able to um, upload the data, and now we've extracted the columns that we need into variables k and h. So now that we have our list, we can now do what we've been doing before. So we can import one of the um, any of the functions, and then let's try using the k arithmetic to find the permeability averaging of this system. So if it is k arithmetic that we want to use, you can see, since we've already imported script already here, you don't have to import script again. So, so you can say script.k arithmetic, and then you can pass the k and h that we have here. You can run that and we have our value. So this is 8. It's not really that um, difficult to do. I hope there's no problem with this one. Okay, so we'll try our hands on this one again. There is another file called gas composition, and we want to use that to calculate the gas gravity based on the composition of the gas. So let me open the file so that you see. Yeah. So there's a gas which is a mixture of gases, methane, propane, butane, and stuff. So we have the mole fraction of each of the gas components, and we have their molecular weights. Based on the mole fraction and molecular weights, we are to calculate the gas gravity of the mixture based on this formula. So multiply the individual molecular weights and fractions, find the sum of the products, and divide by this constant, and 28.97. So now that we understand the question, again, you have to upload the gas composition file into your Google Drive. Okay. So you've already imported pandas, so we don't have to import pandas again. So I'm just going to call this comp, and I'll call the pandas, and we'll call the read excel function again. And then we'll have to pass the location of that file that we are interested in, which is the gas composition file. And we'll copy the path, paste it here. So then you can print the gas composition to see what it is that we have. So we have the gas composition passed, we are only interested in the mole fraction and the molecular weight columns. So you can extract those. The mole fraction, I'm just going to store it inside a variable called y. So comp or composition, and then we pass the mole fraction. Sometimes the interpreter can give you completions that you can select so that you don't type. And then we just want the values. And then we do the same thing for the molecular weights too. Molecular weights and the values. Okay. So now that we have this, um, we need to calculate this formula here. So I'm going to use the math module. So the numerator, as you can see, is the product of sums. So I'll call the sum math dot sum prod. Now pass the y and the w. Then the denominator, as you know, is 28.97. Alright, so then we can find the gravity by dividing the numerator and the denominator. And then we can print the value. So this is the gas gravity of this system. Yeah, so that is it for reading of files for today. So you can use files from your Excel and then import it into Python and do calculations on them like you would on a normal list or any other object. Any question? No question today. Okay. So if you understood everything, then from next week we'll be building the application that you'll be building to share with people that you've been able to complete the course. Next week is the last week for the first cohort. So for all those who have made it to this point, I congratulate you.